Okay, continuing on with 2.4. So I probably should have done this first little piece with the last video, but I didn't. I'd hit stop too soon. So we're going to continue from here. So it says uses of the remainder in synthetic division. So the remainder are obtained in synthetic division of f of x by x minus k provides the following. So the remainder r gives the value of gives the value of f at x equals k. That is, that r is equal to f of k. So what it's saying is if I plug in that if I plug in that 0, that k value, then it's going to tell me what my remainder is. So if my remainder is 0, then that means that x minus k is a factor of the function. And if r equals 0, then k comma 0 is an x-intercept of the graph of f of x. So if r is 0, then that k value is an x-intercept. It's a 0. It's a root. It's a solution of our function. All right, so moving on with the rational zeros theorem. So rational zeros theorem tells us how we can factor all different functions or all polynomial functions if we don't have a starting point. So on the ones up to now, like they gave us one of the zeros and said, okay, start using this. But what if they don't? All right, so we would use the rational zeros theorem. It says if f is a polynomial degree where our degree is greater than or equal to 1, it's written in descending order of the exponents, then it is possible to make an organized list of potential rational numbers to aid in finding the zeros of the function. So these are potential ones, which means if I have a 0 that's a rational number, which remember, rational number is a number that can be made into a fraction. It's not it's not like the square root of 2. It's not going to be pi. It's not going to be imaginary. It's going to be a rational number. And so these are just the potential ones. So if I have, if I have a 0, a root, an x-intercept, or a solution, that is a rational number. It will be in this list. All right, so to find this list of numbers, though, you're going to take the factors of the constant term as your numerator, and we call it p, and you're going to divide that by the factors of the leading coefficient, which we call that q. And so you're going to take your p over q, and so you'll hear me refer to it as using your p's and q's. All right, so let's try this. On example 7, it says find the rational zeros of f of x equals x cubed minus 7x minus 6. So first we're going to go find our p's. And remember, p's are the factors of the constant number, which in this case is a negative 6. It doesn't really matter if you put the negative or you just put the 6, because when we do the factors, remember 6 is divided by 1, but 6 is also divided by negative 1 then. So all of ours are going to be plus or minus. So 6 divisible by 1, it's divisible by 2, it's divisible by 3, and it's divisible by 6. Now, one way to do this is it's kind of like when you were doing a quadratic, you knew how the numbers would repeat themselves. Well, 2 times 3 is 6. So if I don't know what my next number is, I know it's whatever I would multiply 1 by to get that 6, okay? So I know on these it's not too hard, but when you end up with like 400, then you're going to want something to find you a pattern, okay? All right, so there's my p's. Q. Q's are going to be the factors of the leading coefficient, which in this case is a 1. And the factors of 1 are just plus or minus 1. So now to find your p over q, you're going to take every p and divide it by every q. So we're going to take 1 over 1. And I always put plus or minus, okay? I'm just saying the digit, but it's plus or minus. Then we're going to take 2 over that 1, that's a q. We're going to take 3 over the 1. And we're going to take the 6 and divide it by 1. Now this one just happened to be that q was only one number. But if I'd had another number over here, then I would have to do it again. 1 over that other number, 2 over that other number, 3 over the other number, 6 over the other number. And if there's another one, we'd do it again and again and again until we don't have any, okay? So, and also when you're doing your list, you don't put repeats in it. So if I had a second one here, And when I divided 2 by it, let's say it gave me 1. Let's just say it was a plus or minus 2. So if I took 2 and divided by 2, it gives me 1, but 1 is already in my list, so don't write it again. All right, so back to our actual, let me get rid of that plus or minus 2 there, and the comma. Whoops. All right, so we said this was plus or minus 1. All right, so if I have a 0 that is a rational number, it is in this list right there. So we're going to just pick one to try it. So what if we try a positive 1? So I'm going to do my synthetic division. Remember, if it's a factor, its remainder will be 0. Or I shouldn't say a factor. If it's a 0 or an x-intercept or solution or root, that 1 there, our remainder should be 0. So I'm going to do my coefficients. So I have 1x cubed. I have no x squared. I have a negative 7x and a negative 6 for my constant. So bring down the 1, and then 1 times 1 is 1. Combine them, 0 plus 1 is 1, times the 1 on the outside there, so we get another positive 1. Negative 7 plus 1 is negative 6, times the 1 outside there. 1 times negative 6 is negative 6, and that gives us negative 12. It's not a 0 as my remainder, which means 1 is not a solution. It's not a 0 of this function. So then you're just going to try another one. So let's try negative 1. Now typically I don't use the plus or minus 6, okay? Very seldom have I ever seen it work. So I only use it if I have to, but I don't have to. All right, so let's use our coefficients again. So we got 1x cubed, 0x squared, minus 7x, and then minus 6. So bring down the first term. Negative 1 on the outside times 1 is negative 1. Combine them. 0 minus 1 is negative 1. Times the negative 1 on the outside is positive 1. Negative 7 plus 1. Forgot my remainder box. Negative 7 plus 1 is negative 6. Times the negative 1 on the outside is positive 6. And we get the remainder of 0. And so we're happy because we found one. So I'm going to go ahead and I'm going to write me a box over here for my answers. And so let's see. My first one I just found was negative 1. Now, how many should I have total? I should have 3 of them. So let's go find them. Now, this one said to find the rational zeros, but there is a chance they could be imaginary or they could be irrational, okay? But we're going to go ahead and find them, whichever way they are. So after I did this, I know that my equation that I got is x squared minus x minus 6. And so we're going to set that equal to 0, and either we're going to factor it or we're going to use our quadratic formula. This one is factorable, so I'm going to go ahead and do that. So I get x times x to give me the x squared, and then I need two numbers that multiply to 6 that are going to subtract to the 1, which is 3 and 2, negative 3, and a positive 2. Now, we're looking for the zeros, so we need to set each of those individually equal to 0 and solve. So I got x minus 3 equals 0 and x plus 2 equals 0. Move the 3 and move the 2. And so we got x equals 3 and x equals negative 2. Now both of those are rational numbers, and look in your list of potential ones. That p over q, are they both there? They are. So we have found our, oops, that's a positive 3, sorry. We have found our 3 zeros, and so we are finished with this problem. So moving on to example 8, we're doing the same exact thing. So we're finding the rational zeros of a different equation now. So p is going to be the constant, the factors of the constant, which is a negative 1. That's pretty easy, plus or minus 1. And q remembers the factors of the leading coefficient, which is a 2. So we get, so we get plus or minus 1 and plus or minus 2. So then to find our p over q's, we're going to take every p divided by every q. So we're going to take 1 over 1. And then, well, I'm done with that, with the 1, so then I'm going to take the 1 over the 2, which is 1/2. And so if you ask yourself, how many options do I have right here that are rational? It's really 4 because of the plus or minus. All right, so we need to pick one. And so let's try -1. All right, so for -1, my coefficients are 2x cubed, 3x squared. I don't have an x, so 0x, and then -1. So bring down your 2 times the -1 on the outside. Combine them. 3 minus 2 is 1 times the -1 on the outside. Combine them. 0 minus 1 is -1 times the -1 on the outside. Combine them. -1 plus 1 is 0. So -1 is one of my zeros. So I'm going to come on over here. I'm going to start my answer box. How many should I have total? Well, the largest exponent is 3, so there better be 3. All right, so using these coefficients down here, the equation that we're left with is 2x squared plus x minus 1. And so we're looking for where it's 0, so I'm going to set it equal to 0. And we can factor, or we can use our quadratic formula. So I'm going to try to factor on this one. Let's see if it works. This is, remember, where you take the first times the last, and you put the little 2 to the side. It's gone, so you have x squared plus x, and remember you're multiplying them. So 2 times -1 is -2. Now we have a simple trinomial, just like what we did in the last problem. So I know it's x and x to give me the x squared, and then I need to know what multiplies at 2 that will subtract to 1. Well, that's 2 and 1. I need a positive 1, so the 2 is positive, and that leaves the x then to be negative. Don't forget you multiplied, so you got to divide back out. And so we get x plus 2 over 2 is 1. Now, the next one, we get the 1 over 2. And I know we're just solving, but remember, we need to get used to what if it said just to write the factors. So you can't have a fraction, so you would take the 2 and move it in front of the x. So there's my factors. But we are, after the zeros, the solutions, the x-intercepts, and the roots. So we are going to solve these. I'm going to come over here and I'm going to set them individually equal to 0. So x plus 1 equals 0 and 2x minus 1 equals 0. So I move the 1 and I find x equals -1 is a 0. Well, we already had a -1, didn't we? All right, we'll talk about that in a minute. Then the other one, we're going to move the 1 over. So 2x equals 1 and divide by the 2. And so we got x equals a positive 1/2. All right, so now I've got another -1, so I could write it a second time, or I could say, remember, if it's there more than once, it's got multiplicity of 2, because it's there twice. And then we've got our positive 1/2. So even though I only have 2 of them written down, remember the -1 we're going to put has multiplicity of 2, therefore we know it counts as 2 of them. And so there is my 3 zeros that I expected. All right, number 9, more of the same. So we're going to find all the real zeros of this. So when it says the real zeros, now they're saying, well, you know, you might end up some that are irrational. Irrational zeros would be like the square root of 2, the square root of 5, things like that we could get for zeros. So, but the process is still the same. So let's go find our p's. Remember, p is the factors of the constant, so the -3. Which are plus or minus 1 and plus or minus 3. Q is the factors of the leading coefficient, which is a -4. So could be plus or minus 1, plus or minus 2. Now, remember earlier I told you like how if you find the 2 that are side by side that multiply, you can work your way back out. Same thing here, the square root of 4 is 2. So I know my next number has to be whatever 1 is going to be multiplied to give me that 4 there. And so it would be plus or minus 4. All right, so let's do our P over Q's. So this is where it's really important to have a pattern. So I'm going to take my first P and put it over all my Q's. So 1 over 1, 1 over 2, and 1 over 4. Then I'm going to take my 3 and put it over all of my Q's. So 3 over 1, 3 over 2. Now remember, if any of these repeat, if I already got them written down, I'm not going to write them a second time. And then 3 over the 4. And so none of these did repeat, but if they did, I would only write them one time. You don't want your list to be any bigger than it has to be. All right, so there's my possible ones. And so we need to pick one to start with. So how about 1? 1's always a good one. So I'm going to put a 1 in the corner here. My coefficients are negative 4x cubed, 15x squared, minus 8x, and then minus 3. Didn't have to put any zeros in it this time. They were all there. So bring down your first term. Multiply it by the 1 on the outside. Combine them. 15 minus 4 is 11. Times the 1 on the outside is positive 11. Negative 8 plus 11 is negative 3. Did I make a mistake? Times the 1 on the outside, which is negative 3. And so I ended up with negative 6. I didn't make a mistake. 1 is not one of my zeros. I didn't get a 0 in the box for remainder, so 1 can't be a 0. So pick another number. How about negative 1? So use the same coefficients, so negative 4x cubed, 15x squared, minus 8x, minus 3. Bring down your first number. Multiply it times a negative 1. Combine them. 15 plus 4 is 19 times a negative 1. It's negative 27, which is not 0. So I had to make a mistake in one of these. I know one of them should have been. Let me check. Check the first one. I thought it was positive 1. So bring down the negative 4 times 1. 11 times 1. Oh, right there. Okay. So let's go back to the first one. I am so sorry. My mistake is, let me change colors here. My mistake is right here. Negative 8 plus 11 is a positive 3. Times the 1 would have been a positive 3, which would have gave us 0. I'm so sorry, guys, but I've been on this video for 17 minutes. I'm not starting it back over. All right, so we did find that positive 1 was a 0. So what I've got down here at the bottom, then we have negative 4x squared plus 11x plus 3 is what we have left. I'm going to go ahead and do my 0 box. And so we found 1 was one of them. All right, so now I'm going to set this equal to 0, and I need to solve it. Now, because it's equal to 0, guys, we don't like negative in the front. I mean, when factoring, we'd have to use quadratic formula, I think. But remember, because it's equal to 0, we can get rid of the negative by dividing everything by a negative 1. So it ends up with 4x squared minus 11x minus 3 equals 0. And now this one is factorable, or you could still use your quadratic formula. So when I go to factor this, it's first times the last. It's off in cloud or space here. It's gone. Remember, it's times, so we get minus 12. Simple trinomial. So x and x. We'll multiply to 12. That will subtract to 11. It's going to be 12 and 1, minus and plus. Remember, you multiplied. You got to bring it back and divide. And so we end up with x minus 3. I can't divide the second one. I can't even reduce it. So then we get 4x plus 1 as my factors, and it's equal to 0. So remember, then you're going to set them each individually equal to 0. So that's minus 3. Excuse me. X minus 3 equals 0, and 4x plus 1 equals 0. So move your 3, and we got x equals 3. Subtract the 1. 4x equals negative 1. Divide by the 4, and we get x equals negative 1/4. And so there's my other two zeros. So I got 3 and negative 1/4. Of course, all of those are rational, and so you can look in our list, and we had a positive 3, and we had a negative 1/4 in there, so they were there as well. Now, what would happen, we don't have one like it here, but what would happen if I had an x to the 4th at the very beginning? You've got to get it down to x squared so you can use your quadratic formula or you can factor it. So if you have an x to the fourth, you're going to need to find two rational numbers out of your p divided by q's that will work. All right, so moving on. 10 says find a polynomial function with a leading coefficient of 2 that has a given degree in zeros. The degree is 3 with zeros at -1, 3, and -5. So they told me the degree is 3. What does that mean? Well, one thing is it means I should have 3 zeros, and I do. It means I will have 3 factors, one for each zero. And it means that when I write this out as a polynomial form, then my largest exponent is going to be x to the 3. All right, so to do this, the first thing we're going to do is we're going to list out our zeros, because later we're going to get to some stuff where we don't have all of our zeros, and we're going to have to go find some using other information that they give us. So I have a 0 at -1, 3, and -5. Now I'm going to take those zeros and I'm going to rewrite them now into factors. So I'm going to put them back in with the x. So that -1 would give me the x plus 1. Remember, the sign changes when it comes away from x, so you change it when you put it back. The 3 would give us x minus 3, and the -5 would give us x plus 5 as a factor. So now I'm going to write it in factored form. The only difference between factors and factored form is you're going to put f of x equals at the beginning, and you got to put the leading coefficient. So we're going to write it as f of x equals, we know our leading coefficient, it tells us is 2, and then it's times our factors. Now, if the directions here had been to write this in factored form, we would be done. But it wasn't. It was to find the polynomial. So it wants it in polynomial form, which means we're going to multiply all of this on the right side of that equal sign. Now, I know it seems like a lot, but look, we've got 4 things, so we can split it. Multiply the first 2, multiply the second 2, and then we'll multiply their answer. So let's do that. So I'm going to distribute the 2 to the first one. I'm going to put it in parentheses because it's still going to be multiplied times whatever we get at the other one. And then we're going to do FOIL here. So we get x squared plus 5x minus 3x minus 15. And then I'm just going to clean up that second parenthesis sum. So we got the 2x plus 2 times x squared, 5x minus 3x is positive 2x, minus 15. And so now I need, oops, I don't know why I closed that parenthesis after the 2x, I'm sorry, minus 15. There we go. All right, but now we still need to multiply them. So guys, I'm not going to try to distribute because that gets messy to me. I'm just going to go ahead and do this in a box. So I'm going to have this box here, and I need to make it a 2 by 3. Doesn't matter if it's 3 going across or 3 going up and down, okay? So I'd have my 2x plus 2, and then I have my x squared plus 2x minus 15. And so we're just going to multiply these through. X squared times 2x is 2x cubed. X squared times 2 is 2x squared. 2x times 2x is 4x squared. 2x times 2 is 4x. Negative 15 times 2x is negative 30x. And negative 15 times 2 is negative 30. All right, so when we pull this out of that box, combining our like terms, then we were going to have our polynomial function. So I'm going to write it down here at the very bottom. I'm going to go ahead and put my f of x equals. And then look, we have only one thing that has x cubed, so I got 2x cubed. And then I've got 4x squared plus 2x squared because it's positive, which gives me a 6x squared. I have negative 30x plus 4x, it's negative 26x. And then I have the minus 30. And so here is my polynomial function with all the stuff it gave me. And then number 11. Number 11 says use the intermediate value theorem to show that f of x equals x cubed plus 2x minus 1 has a 0 in the interval from 0 to 1. So we did this back in 2.3. So remember, to show that it has a 0, that means that one of the y values needs to be negative and one of the y values needs to be positive. So we're going to plug in 0 into our function and then 1 into our function and see what their y values are. And if there is a 0 between them, their y values are going to have different signs. If the y values have the same sign, then there's not necessarily a 0 between them. All right, so let's find f of 0. So I have 0 cubed plus 2 times 0 minus 1. Well, 0 cubed is 0. 2 times 0 is 0. So we end up with just the negative 1. Then let's find f of 1. So we get 1 cubed plus 2 times 1 minus 1. 1 cubed is 1. 2 times 1 is 2. And then minus 1, that gives us a positive 2. So we can see here that 1 is negative, 1 is positive. So the intermediate value theorem tells us there is a 0 then between where x is 0 and 1. So we're going to write that as by the intermediate value theorem. We know there is a 0 in the interval (0 to 1) because f of 0 is negative and f of 1 is positive. And so, guys, hopefully this makes sense. So if you think about it graphically, it says, let me come down a little bit more. It says 0 has a y value of negative 1, so it's down here. 1 has a y value of 2, so it's up here. So if I'm going to draw the line between them, I have to cross at some point that x-axis. And so somewhere in here, there is a 0. There is a root, there is a solution, there is an x-intercept, because I have to cross the axis to get from one point to the other. All right, so that's the end of 2.4, and we are ready for our first test in Chapter 2.